Good morning, everybody. Good morning. Thank you for everyone that decided to come this early to the first of the lightning talks. Really appreciate it. We have a couple speakers before Emily comes back, and we have keynotes coming back. So let's welcome them up to the stage to get ready, and we can kick it off. Right?
Indeed.
I think everyone's still waking up, waiting for the coffee to kick in. All right, so first up, we have Jeff, who's giving us a talk on teaching Python for community outreach. Let's give him a very loud round of applause because there's not many of us here.
Hi, everyone. Thanks for coming up this early. I'm Jeff. I'm a bioengineer at the Rehab Neural Engineering Labs at the University of Pittsburgh. But I'll be talking a little bit about teaching Python and community outreach. So this is a picture of my lab from a couple years ago. We've grown to this large group. I have our lab mission up here, but I'm not really going to talk about that if those words confuse you a bit. I'm happy to talk about it if you find me later. But I'd like to show that in the past couple of years, especially, my lab has formalized a list of both scientific and community values. And we've really emphasized that, it's not just about doing the technical work and the science, but we've emphasized, the importance of dignity and respect, diversity, equity, and inclusion, actually being anti-racist, not just not racist. There's a difference. Of course, especially in education, there's always been a big focus on mentorship and training. That's what education is all about. And I think these ideals, really overlap with open source software too, right? Like, we want to share knowledge and provide opportunities to all with this software. These are just some important things to keep in mind. And I'd also like to talk about the context of my university in the city that we're in, Pittsburgh. So if you've never been to Pittsburgh, it's a pretty cool city. I recommend checking it out. We are surrounded by these three rivers, so most of the city kind of forms this triangle. And so on the left side here, on the west, we've got downtown. That's really just a triangle area. I've highlighted the university in red, where it's in this neighborhood called Oakland. We've also got Carnegie Mellon University, our neighbors to the west, also in Oakland. So it's this really big kind of second downtown area that's this like hub of education and technology. But in between that and the main downtown area is this neighborhood called the Hill District. It's actually like this really big hill. And of course, these are our literal neighbors in the city. This was like, it's an interesting neighborhood. Especially in the earlier decades of the 20th century, it was actually known as Little Harlem. It was this really thriving center of African-American culture, and especially like jazz, things like that in Pittsburgh. But like many cities in the US, it unfortunately faced a lot of decline and issues later in the 20th century. I highlighted here that they constructed these highways and they put up some sports arenas. They actually had to knock down housing to do that, and they kind of cut it off from downtown. And so now it's seen as this really disadvantaged neighborhood after that. It's really unfortunate. But these are our neighbors, and we'd like to engage with them and help change things for the better. So some of the grad students in my lab planned this Intro to Python course. The university actually has this community engagement center in this neighborhood. Something I'd like to emphasize is that the students who put this on are not expert coders. I mean, they are bioengineering PhD students primarily. But they planned some short lectures to go over the fundamentals of programming, things like variables, control flow, loops, functions. But actually, most of the course time was spent just doing programming practice. And we really emphasized one-on-one help from volunteers. So we got a big group of volunteers from the lab. We had different people come each week, but we tended to have about as many volunteers as students, which really meant we could do one-on-one time throughout like the whole class. We had a lot of interesting students of various ages. We kind of targeted adults, but they ranged from high school age to senior citizens, different career backgrounds. Some had a little bit of programming experience, most had none. One woman shown here actually brought her son with her, which was really cool. He was interested as well, even though he was very young. So since we had all these different ages and career levels, the one-on-one tutoring really helped. And the course ended with some final projects where they had 2 weeks to work with us to do something really creative and really impressive considering how little time they had to learn. They did things like creating password generators, actually creating a Python tutorial and cheat sheet in Python, music playlist, and like games like Hangman. And we ended with this graduation little ceremony where they presented their final projects. And the feedback from the course was really great. They wrote these sticky notes. We tried to teach them, how they could learn more in the future and keep this going. And so it was just a really great experience, and I hope this encourages, more people to do something like this. Remember, you don't need to be an expert at coding or teaching to do something like this and to give back to your community. So with that, I'm out of time, so thank you.
Thanks. And I realized I forgot to explain what I was doing up here with my fingers. If you haven't seen lightning talk before, I was tiny clapping, which is what we do as the speakers get close to their 5-minute mark to give them a little signal, time to wrap it up. Lorena?
Yeah, I was going to say, as someone from Chicago, I can connect with the cool Python teaching, all that jazz. So thank you so much for speaking. And up next, we have Jessica, and I am very intrigued what we're going to hear.
Good morning, good afternoon, good evening, guys, gals, and non-binary pals. My name is Jessica, and I'm a data engineer at Elastic. I like to call myself a career data pusher, but I also do a lot of automation engineering and scripting in my current role. And most importantly, I am a devoted cat mom, which may not be relevant to this talk, but is pretty relevant in general, so you should know that. Now, over the next few minutes while you're enjoying your coffee here in the PyCon ballroom, I am going to change your life. I'm going to tell you how removing one word from your vocabulary will not only make you a better developer, but a better teammate and mentor to those around you. This is a personal philosophy of mine, but I think it will work for you. Maybe not exactly, but I hope you get something out of this. So a little bit of background. My previous job was at a consulting company where I spent most of my career there as a data-adjacent developer in some way, shape, or form, starting in the humble role of data warehouse developer in 2014. As a data dev, and if there are any data engineers in the audience, you may feel this as well, you get a lot of questions along the lines of, hey, why are the numbers like this? I would, as best I could, explain how the data pipelines work, but I'm not the business owner of the data, so if there's some issue with the source data, that's not really my purview. I can only explain how data gets from A to B, how C is transformed into D, but not why the source value N was correct or incorrect. So one day, during a stint with my second data warehousing client, I was chatting with a business analyst about a dashboard, and she was confused about a few numbers. To her, they just did not make sense. I was, as usual, explaining limitations of what kinds of things I could do, like why the source data couldn't fit into the report she was expecting. But she just looked at me and said, why can't you just do this thing with the data to make the numbers better? Which, what does better even mean in this case? Then a couple months later, I was transitioning off this client, and I was handing the work off to another consultant. As I was explaining a rather complex data pipeline, which needed much ugly manipulation to even get from source data to a number resembling the output, he looked at me and said, but why didn't you just insert technical solution that obviously works because I don't know the context of anything that you're talking about and clearly you should have done instead? I hope you can all see where this is going. Since these two occurrences, I have been on a campaign against the word just when posing a question with someone I'm working with. To me, just implies that the person you're asking a question to is missing something so obvious, so inconceivably unmissable, that they should have thought of it in the first place. With the first story, the BA was saying it kind of out of frustration. There was a number she didn't understand and wanted to have me fix it. But the second one, it was definitely with an air of arrogance, this idea of like, I didn't know enough to do the correct solution. So by phrasing the question in a way that promotes discussion rather than blame or ignorance, which in my opinion is what just implies, you can go much farther and maybe even learn a little something along the way. So here are a few of my favorite ways to rephrase can't you just. So like, what if we tried? What if you did something? Have you considered? Did you know about? Next time you come across this, would you be able to explain why? And to me, taking the time to rephrase this question may even get you thinking about why it even came up in your mind in the first place. Like, was there something that I missed, or is there something I didn't consider? So to me, phrasing questions in this way paves the way to more understanding teams and colleagues who are willing to learn from one another. Also, if you find yourself using it, don't worry, I caught myself using it in this presentation. So basically, be gentle to yourself. Know that you're all learning. As an ex-jerk programmer, every day I'm still thinking about how I can remove this word and be kinder to especially the junior devs around me. We don't know everything. Some of you may all know that XKCD comic of like every day there's like one person who's learning something that you thought was very obvious for the first time. So I'm here to leave you with this very relevant motivational poster, which is if your question starts with "can't you just," the answer is no. Thank you for listening to my talk. Come find me at the Elastic booth. I'll be there around 11 if you want to share cat pics with me. All these photos come from the Canadian Internet Registration Authority. They have the best stock photos on the internet, and you should use them. Thank you so much.
I think Lorena's getting her phone out now to show you cat pics on stage.
I'm sorry. I'm so sorry.
I love that talk. Another word I strike from my vocabulary is simply. Like, nothing is actually simple. Just stop saying simply. All right, next up we have Roy with Biometric Attack. Let's give a hand to Roy.
Hi, my name is Roy. I'm a security software engineer, and today we're going to talk about biometric attack. So, is anybody at the audience use Face ID like I do or any other equivalent technology? Cool. Have you ever stopped for a moment and thought to yourself, how does magic actually occur? How you can show your face to the phone and the phone recognizes you as yourself and unlock itself? And more importantly, have you ever thought how secure is it? So let's dive straight into it. When your phone sees a picture of yourself or any other person, it firstly detects where the face is inside the picture, and using a deep learning algorithm, provide us a feature vector of that face. Those features can be anything from the length of your nose or something weird as the ratio of your eye length and your mouth. We don't really know what's the meaning of those floats, but because they are generated by a deep learning algorithm. But we know that this feature vector, which is sized 128 most of the time, is supposed to represent you very well. So all your phone has to do is save this feature vector inside of it and compare every new photo to that feature vector. So let's simplify things a little bit. I will take this 128 feature vector and make it into a 3D vector, so our monkey brain can comprehend better what's going on here. So point A is our first scan. When we bought our new iPhone, and we don't really try to match that exact point, because today I'm looking a bit different than I looked yesterday. My hair is a little bit longer. I didn't shave. So we're trying to do some circle, some sphere around that point, that everything inside the sphere, like point number C, which is a bit different than point number A, represents me. Point number B, on the other hand, is very far, which means it's not me. It's probably one of you who tried to hack my phone. So now we understand the process. We got a picture, and deep learning algorithm provide us a feature vector out of it. So we've got ourselves a feature vector, which is a representation of our face. But is this representation any good? Let me show you something a bit weird. So we try to put many, many images of many, many people into many, many iPhones. And most of the people got exactly one hit. They were able to open their own phone. But this dude here at index number 27 has something really weird going on with him. He was able to unlock more than 50 phones with his face. So let's try to understand how's that. So if we take the example from before about the length of your nose, most noses are 2 inches or 5 centimeters for non-American friends. And although you can have a little bit of bigger nose or smaller nose, most noses will be at that range of 5 centimeters. And we found out that most of those features are normally distributed as well. Now, let me shock you. We were able to hack a phone 13 times in 1 million attempts, which means your phone is secure as in 5-digit numbers. So let me show you how this attack was done. We generated here many, many faces. We as a human can see that those faces aren't real at all. But because we were able to generate the distribution map for each feature, we could create the most generic faces from most generic to least generic. And during this attack, find a face that will be close enough to yours, in terms of iPhone and unlock your phone. So no one is safe. Thank you very much. This is my mail, and please feel free to approach me with any question.
Thank you so much for your talk. Up next, we have Gajendra continuing on a really relevant topic on security.
Good morning, everyone. My name is Gajendra Deshpande, working as Assistant Professor at KLS, Kolkata Institute of Technology, India. So I'll be delivering a short talk on security considerations in Python packaging. So in brief, we are going to discuss 3 tools. One is Bandit, second one is safety, and third one is SemGrep. So why hackers are targeting Python is that we know that Python is gaining lots of popularity, and especially in TOB index, it has reached #1 position. And even in Stack Overflow, it has been ranked 3rd. And even on GitHub stats, you can see that in terms of number of active repositories, Python is on 3rd position. Now there is a general misconception about the security of the open source software. So some people cite that the major reason is that the code is open source. The code is available to everyone. But generally speaking, open source softwares are secure by design. And security issues are mostly due to the lack of understanding of secure coding principles. And Python is secure, but vulnerabilities may be present in the Python packages. So importance of secure package is that insecure package will make your application vulnerable and prone to external threats. Compromise and unauthorized disclosure of information may result into personal and company reputation and money. So unsecure code may damage the system of users, and sometimes it may also lead to the physical damage. Now these are some of the articles which you can go through later. So these articles have been published recently, and they have highlighted several security issues such as dependency confusion attack mounted via PyPy repository, then JFrog detects malicious PyPy packages, stealing credit cards and injecting code, and potential remote code execution in PyPy, and supply chain flaws found in the Python package. Let's see the Bandit tool. It's a tool designed to find common security issues in the Python code. So to do this, Bandit processes each file, builds an abstract syntax tree from it, and runs appropriate plugins against AST nodes. So once Bandit finished scanning all the files, it generates a report. So this is how you can use it. You can run it independently. You can run it against a code repository. You can also specify a profile. So in this slide, the shell injection profile has been mentioned. So you can also write your own custom tests using Bandit. So there are some plugins, and these are the various types of tests you can perform, and there are various tests. These are the categories. So these are the tests under those specific categories. The next is the safety check. So safety checks your installed dependencies for known security vulnerabilities. By default, it uses the Python vulnerability database SafetyDB, but can be upgraded to use pyapp.io safety APIs using key option. It supports Python 3.5 and above versions. Now how to test it is by installing an insecure package. So these are some of the commands how you can use it. So this is a screenshot you can find out. This is the screenshot before installing insecure package, and this is the screenshot after installing insecure package, and you can see that it has appeared here. But these are the insecure packages installed on my machine. Now you can use SafetyDB. It's a database of known secure vulnerabilities in Python packages. The data is made available by pyapp.io, and it is synced with the repository once per month. So you can visit the URL mentioned here, the first URL, to see the list of insecure Python packages. It doesn't mean that just because it appears in the list, it is insecure. So there are some SafetyDB tools which you can use. The safety CI, safety Django, then safety bar, pip and check, and so on. The next one is the SemGrep, which is the open source static analyzer. It works on mostly 17+ languages, supports Python also. It is not vendor controlled, and 1,000+ community rules have been written. You can write your own rules. It addresses OWASP top 10 issues, and it hunts vulnerabilities by iteratively exploring a code base with lightweight queries and REPL workflow. So there's a link of Playground which has been mentioned here, semgreps.dev/editor. You can just visit the link and see how it works, and you can explore. Then general guidelines that if you are a package maintainer, then ensure that the package you are maintaining is secure and practice secure coding principles. So as an application developer, follow secure coding principles while writing. Then use tools to check vulnerabilities. Then periodically scan your environment. Sign and verify packages using PGP keys. Use Twine for improved security. Scan packages before upgrading. Ensure that you install code from package from trusted source. Thank you.
Great talk, very interesting to me personally as well. Thank you for giving it. And next up we have Diamond, who's giving us a talk on scaling PyTorch and prod real-world ML with torch.package and deploy. Let's give it away for Diamond.
Hey everyone, morning. I'm Diamond. I'm an engineering manager over at Meta. In particular, I work on PyTorch, which is, I'm sure, your favorite machine learning framework for Python. Apologies if we have anyone here from TensorFlow, but it's a great framework. I'm going to be talking about one of the things that are near and dear to my heart, which is scaling this for production use. Really awesome when people use PyTorch for learning, machine learning, for research, for everything like that. But one of the really important things to me is that we make sure it works really well in production as well. We're going to be talking about one particular aspect of that in this lightning talk, the solution to the GIL problem. Solution put in quotes here because we're not actually solving the GIL problem. Someone much smarter than me is doing that. Instead, I'm looking at a small part of this problem, which is if you're running a production scale machine learning framework or machine learning system, most of the time you actually don't want to just write everything in Python. There's a bunch of different reasons for that. I know it's kind of a hard thing to say at a Python conference, but usually you end up writing your service in C++ or something that is kind of performant, really highly performant, because you want really high throughput. So what you want to do is have this model that you've trained in Python and use it in this potentially C++ or other faster framework service that is very efficient. That's really hard to do unless you take the model and translate it into some other language. Translations are incredibly painful, so instead you want to be able to use Python, run it with C++, and profit. How do you do that? We have two different libraries, two different features that we've actually introduced pretty recently. One is called Torch Package and one is Torch Deploy. Torch Package lets you serialize and deserialize your Python code. Keep your model in Python so your scientists can be happy, your machine learning engineers can be happy. They don't have to do all this messy translations where you end up like losing functionality of Python that you really want, because we do love actually keeping the model in Python, running the model in Python, training the model in Python. But you're able to then deploy that and use it in your C++ system. Under the hood, the way that works for a Torch Deploy is that we have actually an interpreter manager so that you have n Python interpreters. So you're not just running one, because if you were just running one, you'd run into the GIL problem, right, where you have the global interpreter lock that makes it so you can only run in one thread. Instead, if you have, let's say, an EC2 instance or something else that has tons of cores that you're paying for, you can actually use each of those cores. Each core is able to run a copy of your model, and we do that by having a separate Python interpreter per core. An example of this is pretty straightforward. You've got your C++ program. Once you package up your model, you can make a call straight to it. We have here you're loading up the model from your package. Then at the very bottom, you can see that we're actually going to run inference with it, execute your model with the tensor that you're passing. That tensor represents the data that you have in the real-world interaction. So how do you actually put your model into that state? We use Torch Package, which is part 2 of this. It's hermetically sealing dependencies in with your source code, your source model. It's Pythonic, so you can make changes to the dependencies that you're covering with it, that you're wrapping with it, and you have fine-grained control of it. Torch Package example here. This is in Python, not in C++, so it's not as ugly. This is something that you can see. We're packaging up the model. In our situation, we're saying extern is really when you're saying we're going to rely on an external dependency. We're OK with that. It doesn't need to be hermetically sealed. Intern is when you're saying we're going to actually pull this in as part of our package. So this is an internal package dependency. A couple different options you have here. These graphs are hard to parse, so apologies. Real quick, the main important thing is that there's a bunch of different ways, like TorchScript, which is turning it into another language that you can use to make this much faster. Instead, we show that you naturally, without having to do any performance work, are able to get higher performance than your single thread for certain types of models, most small to medium-sized models. Larger models are a bit more complicated. We get some improvements, but not as much as we'd like. Yeah, so here's the public docs. I'm going to actually be hosting an open space as well at 5 p.m. for anyone who wants to talk about PyTorch or machine learning in production. You can come talk to me. We can chat about it. I love to hear your pain points. In particular, I have a whole group that really focuses on how do we make PyTorch better for you, better for production. So if you are using it or you're using machine learning in production and you want something from us, come by. I'm always trying to figure out what else we can do to make it easier and better for everyone. And software's eating the world and ML is eating software, so please help us make that happen. Thank you very much.
I might be at that open space. Up next, we have Manabu, who's going to, I think it's a really relevant topic, so I'm just going to pass it on to you now.
Hi, good morning. I will talk about spread Python community with COVID-19 in Japan. My name is Manabu Terada from Tokyo, Japan. But so I was tough trip from overseas. So, but I came. I could came back to here. Very nice. And I'm board chair of PyCon PyCon Japan Association, and a PSA forum member and more. So we launched the PyCon Japan in 2011, about 10 years ago. At that time, the Python community in Japan was very small. So Masuda-san and Iqbal-san and Ian-san and I took the land. And other Python users who are active in Tokyo and other part of Japan started from PyCon JP. At first, it was only 150 people joined the PyCon JP. Now, we are able to have 1,000 people, PyCon JP. Thank you very much. So, of course, and this year we will have the in-person event in October. If you can come to Japan, please join us. And other activity was being to promote Python all over Japan and create more various community in all over Japan. One of those is a tutorial event, Python Bootcamp. This could be introduced in the poster session in US PyCon 2019. And we supported PyRedis Tokyo, PyRedis Caravan. It is make local women's community and connecting all over Japan. However, you all know, the world has changed in the spring of 2020. But we thought it would not be good to stop, not be good to stop our activity here. So we had some activity. We made some activities. First one, we held Python charity talks in Japan. It was donated to Python Software Foundation. So first time we donated $10,000, and total is at $25,000. So we had 3 times. And other activity, so we have a YouTube Live every month. We share some news of Python and the Python community and introducing some events and new future for the Python 3.10 and more. Last, we are taking the interview for the next PyCon JP TV. And this is Mike, so my PyCon JP TV and staff bulletin. So we will have an open space session at 250F started started at 1330. Please come to the room for the if you have a message to Japanese Pythonista. Thank you very much.
Thank you. And I just want to reiterate that $25,000 donation was really awesome, really helped out the PSF, and the folks at the PyCon JP Association got a community service award, many people, and thanks for that, so thank you. All right, next up we have Jay, who's going to talk to us about DevRel, sharing your company's skills with the world. Let's give it up for Jay.
All right, so I'm going to be honest. I did this lightning talk for two reasons. One, a lot of people ask me, what is DevRel? And I go, eh. And then the other reason is when I talk to all of my friends in DevRel, they all say, hey, do you know anybody that would be interested in a job at DevRel? Like, it's growing. Every company that I've talked to is like, we're hiring advocates, we're hiring content creators. So if you've ever thought that getting up on stage and giving a lightning talk or going to PyCon and getting to walk around and talk to your friends and then getting paid to do that is something that you might be interested in, hey, let's figure it out. So yeah, like I said, DevRel, I don't know. It's a good thing though, don't worry. Every company that tells you what DevRel is, they're telling you what their version of DevRel is. It's going to be different every time. It may change with the seasons, it may change with the weather. And again, this is a good thing because static sites are cool. Static teams and companies, not so much. We have to be flexible, we have to be able to adapt to what is happening in the space. So, your job is to be a communicator. Your job is to communicate to the community that you serve, but it's also your job to communicate to your company the needs of your community. If you're not doing both, I'm sorry, you're wrong. Like that, I'm hoarse, I don't have time to argue that point. If you can't provide value to both the community and your company, then you're doing a disservice to one of those two. So, how do you get into DevRel? This is gonna be the quick 3-minute version. Choose at least one of each of these 3 kinds of things: ephemeral content, a recurring presence, and a longer sustained commitment. If you do more than one, great, you get bonus points. That'll also give you an idea of what type of role in DevRel you want to take on. So we're going to start with the first one, ephemeral content. This is a Twitter space. That's the new hotness. I love Twitter spaces. They're amazing. I did my first one. I was driving, and then I was like, I want to talk, but I also don't want to crash. And that was like, all right, pull over to the side. Tell everybody why this is amazing. Okay, then get back on the road. We'll do safe stuff here. YouTube Live, Twitch. If you've always wanted to tell people to like, follow, hit the bell, do all that stuff, hey, maybe this is a way that you can do that and not have to A, fight the algorithm, or B, worry about subscribers, clicks, and downloads. Or TikTok. I'm not gonna do a TikTok dance. You can't make me, I'm sorry. IG Live, YouTube Shorts, all of these things, all these pieces of content that happen, they're like a flash in the pan, then they're gone. If you like doing that, maybe being a developer advocate is for you. A recurring presence, being at meetups, being at conferences, joining online communities and Discord, Slack channels, appearing on other people's podcasts, doing guest posts and things. These are things where people in the community will see you or at least hear your name. And you don't have to worry about whether or not you did good, because you're going to come back and you're going to do better. You're going to iterate over time. Just like when you're learning to code, your first lightning talk, you're nervous, you're scared. You want to push that button and your buddy Seth is like, don't worry, you got this. That was a true story. That was the story of my first pull request. But the more you show up, the better you get at it. The better you get at it, the more people notice that you're getting better at it. And then the more people are going to want to talk to you, because then you go from being the person that was learning to the person that's now teaching. And then finally, the longer sustainable commitment. This is your blog, this is your podcast, this is your personal YouTube channel, this is your newsletter. This is you posting cat pics on Twitter. Sorry, I've been trying to convince some people to get into DevRel lately, so anything that allows people to see you, know who you are, and feel like they can connect with you and they know exactly where they can find you, that is going to be the thing that you need to focus on. And like I said, it's not just being an advocate. You can be a content creator, you can be a writer, you can get in the video team, you can do all of these things. But I know what you're gonna tell me. I'm introverted. Me too. I'm gonna go home and go to sleep for a few days. You might have ADHD. How do you focus on all these things? Me too. Having a lot of different things to focus on actually makes the job fun and easy. And you can bounce from one idea, and then when you're tired of that idea, you put it down, and then you pick up another one, and then you work on that stuff. And you're not the most tech savvy. That's fine. Your job is to learn and to show people what you've learned. There are a lot of people in the expo hall. If you're interested, you can find me or find someone in a booth and ask them your favorite part, your least favorite part. Thank you.
So I have two Maine Coons who I'm very, very proud of. One of them is named Picard, after Jean-Luc Picard, and all those things. And yes, I do put them on Twitch. I'm very excited for this next talk, and we have Jack.
Yeah, hi, I'm Jack. You might be able to tell by the title of this talk that it's going to be a bit different in terms of content from the other talks. But I'll be talking about what I think is an interesting use of binary search. And I swear this is more interesting than LeetCode. Okay, so as a quick review, I'm assuming most of you are familiar with what binary search is. So we're going to go over an easy problem. So you have this list of a positive number of zeros followed by a positive number of ones. And your task with binary search is to find the index of this first one in the list. So how we can do this is that we have 2 pointers low and high to indicate the current search range. And then in each step, we try to reduce the search range by a factor of 2 until eventually we end at our answer. Okay, so that's pretty simple. So now we're going to look at how we can apply this to solve a harder problem. And this is the problem statement. Partition a given list with n positive integers into k contiguous segments such that the maximum segment sum is minimized. That's a lot to take in, so I think this is best explained with an example. So we have this list here with 10 elements, and we want to partition it into 4 parts. So one way we can do it is like this. So the sums are 10, 18, 6, and 8 respectively. So the maximum segment sum is 18. And this red number here is what we want to minimize. And it turns out that we can actually do better than 18. If instead we partition the list like this, where the sums are 10, 10, 12, and then 8, the maximum segment is 12, and it turns out this is optimal. So to get to solving this problem, it isn't very easy. We have to first make a few observations. So the first observation is that if we fix some number m, it's easy to construct a partition where no segment has sum exceeding m. So here's this function I have called construct partition. We take in a list, k and m, and then we either produce a partition satisfying these constraints, or just for convenience, we return none if no partition exists. So the idea is to just build each segment one by one. And once we get to a point where our segment sum is about to exceed m, we add the segment to the partition. And we're going to keep doing this through the whole list, and you get the idea. So eventually, we end up with our partition from the previous slide. OK, so now with this function construct partition, we can decide whether or not we can partition the list so that the maximum segment sum is at most m. And we can also provide a construction. But what we want is to partition the list so that the maximum segment sum is minimized. So to do this, we have to make another observation. And we're going to look at this funny-looking list comprehension here. Here we're going to construct a partition for just about every possible value of m that might be interesting to us, from 0 to the sum of the whole list. And this list has a few special properties. First of all is that the last element is not none. And this is because any partition has the property that the maximum segment sum is at most the sum of the whole list. And also the elements in this list, which are partitions, are suffix of the list. So if you think about this list comprehension structurally, it's some number of nones followed by some number of partitions that you can construct. And then if you look at the first partition, it also has maximum segment sum of exactly j, if we say that this partition is at index j. And then using the same proof by contradiction logic, we can also show that this first partition is actually our answer. It's the partition that minimizes the maximum segment sum. Okay, but if we treat all the nuns as zeros and all the partitions as ones, this problem of finding the first partition is basically the same as the problem that I discussed earlier of finding the first one in this list of zeros and ones. Okay, so this is the code. That's a pretty short code. And you'll notice that it's actually pretty similar to this first problem that I described. And now I want to take some time to revisit the title slide. So actually, an hour before this talk, when I was preparing, I realized that this is actually a LeetCode problem. Yeah, but nonetheless, I still think it's pretty interesting. So this is LeetCode problem 410. If you want to have a crack at it, maybe during lunch, I think it'd be pretty interesting. And that's all. Thank you.
Thanks very much. All right. Next up, we have Henry, who's going to give us a talk on Scikit-hep developer pages. Let's give it up for Henry.
Okay, thank you. So I want to talk about the Scikit-hep developer pages. So Scikit-hep is a GitHub organization that was built around providing high-energy physics packages. So we have a bunch of high-energy physics specific packages that have been built up over the last few years. You can see a few of them listed here. But we have also worked on some general purpose packages as well. So we have some packages that are there, like vector for vector manipulations, awkward array for sort of a JSON like data structure, but NumPy like access, and histograms. But one of the products that has come out of this is the Scikit-hep developer pages. And this is the most general, I think, of all of these. And that's why I wanted to talk to you today about it. So if you want to find these, you can just go to scikithep.org. It's also linked from my blog, isinumpy.dev. And you'll get to a page that looks like this. You can click on either of these two places, and you'll get to the developer pages. So when you get to the developer pages, you'll be greeted with something that looks like this. You have a variety of different pages there, and then a little guide that sort of walks you through the different pages. These pages can sort of be grouped into these areas. There are some tutorial-like pages that sort of tell you how to set up a development environment, use PyTest, static typing, things like that, including a very nice GitHub Actions tutorial, including how to do binary packages, regular pure Python packages, and a discussion of how you'd use a task runner like Nox. And then there's some specifications. The packaging is in two different sort of groups, sort of classic packaging and the simple or PEP 621 style packaging. And then there's a style guide, and then there's a couple extra tools, which I'll show you, cookie and repo review, that support this. So this is the simple Python packaging page. It's used to be called pure Python packaging, but hopefully this is sort of growing to include some binary packaging soon. And so you have this little toggle here, and you can actually just switch this toggle from flit to hatch to PDM setup tools. The whole page is the same. All this part of the page is the same. It's really just that tool that changes, just those two lines, which is a really nice feature of PEP 621. And so this can be a guide for any one of those. For style, there's a bunch of different things. It sort of tells you how to set up pre-commit hooks for all of these different tools with recommendations for how you would configure these, and sort of just describing sort of what each one is. Now, this all comes together in Scikit-hep Cookie, which is a cookie cutter package. It gives you 11 different backends to choose from. So if you want a setup tools traditional package, or if you want a setup tools PEP 621 or Flit or Hatcher or PDM or several others. And it even has some binary packaging, which you don't see very often in sort of a general cookie cutter. So something with Scikit-build or just plain setup tools C++, or even Rust is supported there. So and to do this, you could just do a pipx run cookie cutter, or however you like to run cookie cutter, and then that's the path that you can put in. And this is all backed by the Scikit-hep developer guidelines, so you're not just thrown at a bunch of different styles and things. You can actually go look up and see why each choice is made and why each package is there. And then there's the Scikit-hep repo review. And this is something that I sort of wrote for myself. This is a rich application. And you can just run this, and it will see how close a repository is to following these guidelines. So it'll go through and check a variety of these different guidelines. There's lots of different ones here, and tell you if it matches or not. And this was really nice, and but it's still something you have to go manually run. So what I've recently done is written the Scikit-hep repo review PyDide app. So this PyDide app sits there in the Scikit-hep developer pages. It's just one of the pages in that list. You can just type in your repository, pick a branch, and click a button. And in your browser, Python, and this is a Python 3.10 application that uses pattern matching and things, but it's able to just run right there in your browser without installing anything and give you a report. It looks like this in your browser, so you don't even have to leave the Scikit-hep developer pages anymore. And a day later, another HEP user took this, because I was also really excited just in this technology and the ability to do this. One day later, another of our Scikit-hep developers took this and adapted it to one of the other packages there. So that was something that was exactly what I wanted to happen from this, and was really, really excited to see other applications. Okay, so thank you very much.
Thank you so much, Henry. I just want to do a quick plug. PyLadies auction is tonight. It's a really great organization, hence the shirt I'm wearing. And it helps us raise money for folks to come to PyCon and do really great things. And all that being said, you should grab a ticket if there's still some left. Now, without further ado, Chris.
Thank you, Lorena. Before I begin, I want to tell you about these words here. They're thanks to a person called Diane, who is a real human being. She's sitting on the other side of an internet and is typing exactly what I say onto this screen for your benefit. Watch this. Septuagenarian, aphantasia, anti-disestablishmentarianism. Thank you, Diane, and our other captioners. Okay, hi, my name is Chris. Please tweet me at the handle on your screen. I'm here to tell you to stop running your tests. But Chris, I hear you saying, tests are how I am confident that my code works. And that's true. Having good test coverage is a great way to be absolutely certain that your implementations are correct, and making sure that you don't break things as you develop. But on the other hand, tests have a lot of problems. They're slow. When you run your full test suite, most of the tests you run are irrelevant to the changes you're making. But your test suite is only correct if you run the entire thing. But you don't run your entire test suite except in CI because it's slow. So in short, you have tests, but you don't run your tests. You have no tests. What would be better is if you could keep not running your tests as often as you do now, but still know which of your tests are correct. That world actually exists. I'm a maintainer on an open source project called PantsBuild. We're a tool that orchestrates all the other tools that you use to interact with your code. That's everything from linting and formatting through to testing and packaging. Our goal is to make the Python tools you already use more efficient than they are in their default configurations, even on huge code bases with complex interdependencies. We do that by identifying work that can be run in parallel or redundant or duplicated work, which will save you from having to run at all. Watch this. You can run an entire test suite. That is not surprising. You can see we run PyTest under the hood, and it runs all 5 of these test suites in parallel, but it only takes 20 seconds wall clock time to run this 60-second test suite. That's great, but not completely surprising. A lot of test runners do this. What else can we do? Well, if we change one of the test files and rerun the entire test suite, it looks like this. It looks like it runs everything, but it actually doesn't. All of those tests that we ran before and we didn't change get reused. Only the test that we changed gets rerun. That is because Pants will cache every single run down to the process level. That's what this memoize thing means. Our 60-second test suite takes only 10 seconds to run now. But that's still not surprising. A lot of test runners do this. Let's reset that change and run those tests again. Pants will cache every test run, not just the most recent one. If we run a command that's identical to the one we've run before, Pants will pull all of those test results out of the cache and reuse them. Our 60-second test suite will now run instantly. Now, what if instead of changing a test file, we change an implementation file that is under test? We can rerun the entire test suite, and this time, the only test that we rerun is the one that tests the implementation file that we changed that we're testing. With this, you can make all the changes you want to your implementation files that you like, and you can rerun the entire test suite, and Pants will only rerun the tests that the tests where you change the code. This is because Pants does automatic dependency inference. It will do static analysis on your code base, and it will figure out all of your Python code's dependencies automatically. This Pants dependees command will show that dependency analysis for you. And again, it has figured all of this out automatically. We didn't need to do any configuration. This is all the configuration we needed to do. We just said there are some source files, said there are some test files. If you've ever written a build file before, you know how short this is. You don't have to map any dependencies yourself. Our static analysis, if it misses a dependency, you can add it manually, but normally you don't need to. And you don't even have to write this file yourself. We have scripts that will automatically generate all of your build files. If this is interesting to you and you want more of a demo, or you want to talk about how Pants could help in your code base, you can find myself or Benji or John. They're wearing shirts with the Pants logo on it. I've got a talk on Sunday at 1 o'clock about how Pants does all this fine-grained caching underneath the hood, and we'll be sprinting on Monday, where we will help you run Pants on your own code base. So come find us at the rest of the conference. That is how you can use Pants to stop running your tests unnecessarily. My name's Christopher Neugebauer. Thank you very much. Cantaloupe.